Hello and welcome everyone. In this tutorial series, we will discuss about the implementation of Python multi-threaded programming. And here in this tutorial, we will learn about the concept of multi-threading, which is one of the most common techniques to achieve multitasking in Python. So we will start off this video tutorial by discussing what is concurrency in Python. Then we will discuss about the concept of parallelism. Then we will discuss what is a thread, and from thread we will move to multi-threading, and we will discuss the implementation of multi-threading in Python. And in the last, we will discuss about some of the constraints of Python for concurrent application or concurrent programming. So without any further delay, let's jump to the very first topic. Basically, multi-threaded programs always use both concurrency and parallelism, yet there is a lot of misunderstanding regarding their similarities and differences, and people usually consider both concepts of parallelism and concurrency as same. However, the short answer to this issue is no. Concurrency and parallelism are not same, even though both concepts sounds similar. So let's discuss about both of them and let's understand the difference between them. Now let's understand what is concurrency. Generally, the occurrence of two or more events simultaneously is known as concurrency. Concurrency in terms of programming is a process of two tasks running concurrently, and it could occur when an application is working simultaneously on multiple tasks. Because we may handle the request concurrently rather than waiting for a prior one to finish, concurrent programming can improve the performance of our application and software systems. We can now get better concurrent solutions because of a remarkable advancement made by some of the programming languages such as Rust, Golang, and Python is also there. So we will discuss about how to achieve concurrency in Python. Let's move forward and let's discuss about parallelism. The art of dividing jobs into smaller ones that may be processed simultaneously is known as parallelism. It contrasts with concurrency, which is the simultaneously occurrence of two or more events, as we have discussed earlier. Parallelism is the simultaneously execution of many instructions sequences, where concurrency is simultaneously management of multiple instruction sequences. Python uses threading to implement concurrency, while multitasking is used to implement parallelism. Let us start with threading, and for this, first we will discuss what a thread is. So, in terms of computer science, a thread is a component of a process which is executed independently or according to a schedule set by our operating system. Additionally, it is the lowest processing unit that a operating system can perform. A thread, in simple words, is a group of such instructions that can run separately from other part of our program. So from this we got an idea that thread is the smallest processing unit. Now what is multi-threading? Multi-threading is a popular threading technique in Python that allows us to run multiple threads simultaneously by quickly switching between them. Moreover, it enables the primary threads inside a process to share their storage space with one another and communicate with one another more easily rather than they could do as a separate process. So in order to achieve several activities at once or in parallel, multi-threading is used. This boosts an application's efficiency and renders its output more effectively. Now let us discuss some of the advantages of using multi-threading. Multi-threading guarantees efficient use of computer system resources. Applications using several threads are more responsive. Multi-threading is more inexpensive because it distributes resources and it stays with child thread. Now, due to the similarities, multiprocessor design is more efficient. Moreover, by running several threads simultaneously, it saves a lot of time. And to store several threads, the system does not need a lot of memory. As we have discussed earlier, for multi-threading, it uses the common storage space. Now, I hope with this you all get an idea related to multi-threading. Now let's move forward and let's discuss how we can implement multi-threading in Python. So in order to manage threads in Python, there are two primary multi-threading modules. The very first one is the thread module and the next one is the threading module. Now if I talk about the thread module has long out of date. It has been declared outdated and it is only used for backward compatibility for Python version 3. Moreover, there is also slight change in the module name. So earlier we just need to use the thread module. Now we have to put an underscore just before the name of the thread module. Now let us discuss how we can use this thread module first. So here on the screen you can see an example. So before its deprecation, we earlier need to use this thread module just like that. So we need to import the thread module, then we define certain functions or we define certain block of code. Then to define a thread, we use this function which is start underscore new underscore thread, and we need to pass the function name as an argument to it. So this is the name of the function, and with this we can pass certain argument to our function. But since thread module is no longer in use, for backward compatibility they have given this module which is underscore thread. So in this example, first we imported the thread module using this, then we defined two functions. So first function name is thread underscore one, and it will simply print a statement that it is executing thread 1. Then we define another function which with name thread underscore 2, and it will print out a statement that it is executing thread number 2. Now how we can define a thread using this thread module? There is a method with name start underscore new underscore thread, so we use that statement. So the very first argument to this method is the name of the function. So by using the thread1 function, we have defined one thread, and here you can see I have passed another empty tuple as a second argument. That is because we can pass certain arguments using that second argument, but for the current stand we will keep it simple. That's why I didn't pass anything. And in the same manner we have defined another thread. So if I start executing this cell, and here you can see the result that first thread 1 has been executed because we defined the thread 1, and then thread 2 gets executed, and this is basically the thread or process ID. Now let's move forward. As the thread module is no longer in use, we will discuss about the second method, which is the threading module. So the threading module is the main standard for controlling multi-threaded programs. In contrast to the thread module, the threading module offers a large range of features. Now to utilize the threading module, we just need to import the threading module just like we imported the thread module. And once we import the threading module, there are multiple methods that we can use to get started with the multi-threading. So very first method that we can use is the start method, which is utilized to start a thread activity. Then there is the run method, which is used to specify the thread activity as well, and an extension of threads class may be override using the run method. In the last, the execution of the further code can be blocked using the join method until the thread has been finished. So there are three main methods related to the threading module. Now let's discuss an example related to it to get more clarity. So here on the screen you can see an example. So as discussed earlier, to use the threading module we first need to import this module. So I have imported the threading module. Then I have defined a function with name get underscore cube, and it takes one argument x and calculates the cube of that value, and it will print the cube. Then in the same manner I have defined another method with name get underscore square, and this will calculate the square and print the square on the terminal. Now how we can define a thread using the threading module? For this we use the thread class. So that's why I have defined this object t1, which is our thread 1. So I have used threading.thread. So here thread class has been used. Now thread class takes two arguments. Very first one is the target. So in target we need to specify the name of our function. So get square is my thread 1. So my thread 1 will execute the get square function, and the second argument to this thread class is the arguments of our function. So I have passed 4 as an argument to my get square method. So what this thread 1 will do, it will execute my get square function with an argument 4. So for the value of x, so basically we have defined the value of x as 4 using this. In the same manner I have defined another thread t2, and this time this thread will execute the get underscore cube function with an argument value of 4. So for get underscore cube also I have defined the value of x as 4. Now next what we have done, we have used the start method with both the threads to start their execution. So both the threads will start their execution. Then I have used the join method so that the thread can wait for the execution to get completed. And in the last, once all the tasks have been completed, it will print a success message that task gets completed. So let me execute this code block now. Here you can see first thread 1 gets executed, that is 16, and the square of 4 is 16. In the same manner thread 2 gets executed, and it has calculated the cube, which is 64, and in the last we got this message that is task completed. Now I hope with this you all understand how we can use the threading module. We will discuss more examples further in this tutorial series. Now let's move forward and let's discuss about the constraints of Python for the concurrent programming. Now Python has a restriction regarding this concurrent application, which is known as GIL, that is Global Interpreter Lock. Since GIL never permit us to use more than one CPU core, we can conclude that Python doesn't have any actual threads. Let us understand this concept in detail. So GIL is among the most diverse subject where this mutual exclusion lock makes things thread safe. So GIL effectively prevents Python code from being executed in parallel by multiple threads. Only one thread can hold the lock at once. Thus, if another thread needs to execute it, we first need to obtain the lock. You can see this whole concept with the help of a diagram which is there. So, for example, we have three threads. We started the execution of thread 1. We started the execution of thread 2. So what will happen? So thread 1 will release its GIL so that thread 2 gets the GIL and its execution will start it, and the execution for thread 1 will lock. For the case of thread 2, whenever it releases GIL, the thread 1 gets the GIL and the execution for that is move forward. And when thread 1 releases GIL, the thread 3 gets GIL. So in this way, the concurrency is being maintained. But actually, you can see that not all the threads are executing at once. There is a state of lock between them. So whenever the execution switches, the previous thread gets in a lock situation. That is the whole concept related to global interpreter lock. Now I hope with this you all get an overview related to multi-threaded programming. We will discuss about more concepts further in this tutorial series. Till then we will end this session here only. So thank you so much for watching this video. We will see you in the next one.